EE World, I'm Martin Rowe. We are in the MenloMicro booth at APEC2024 in Long Beach, California. And Chris Giovanello from MenloMicro is going to explain to us about using the company's, what they call the ideal switch, versus some switches over here made of silicon carbide. And what these switches do is they're run in a combination of series and parallel to bring up the voltage and current. And Chris is going to explain how this works and why the company is saying that their switch runs at a lower temperature than the silicon carbide. So Chris, why don't you go ahead?
Sure. Yeah. Thanks, Martin. What we're demonstrating here is an example of the scalability of our ideal switch technology for handling massive power levels. In this case, we're using a bunch of our MM9200 devices, which is our latest power switch using our ideal switch technology. This is a 300 volt, 10 amp rated power switch. And what's really nice about it, because it's so small, is you can pack them into these arrays like what you were just showing here earlier, where we built an array of 12 in parallel, 2 in series. So that gets us up from 300 volts to a 600 volt breakdown voltage, and pushes the current levels from 10 amps up to, in this case, we'll be showing you running at 40 to 60 amps, but much higher current levels. And we're trying to show a comparison of, in a given, when you have a very small area, how can you limit the heat that's being generated to, be able to handle the most current in the smallest area possible. So we took some silicon, very, very good silicon carbide devices. We fixed the board size at about 40 by 50 millimeters, and we fit an array as many, we could fit into that area. There's a 4x2 array, which you need 2 silicon carbide devices for the AC because it's unidirectional. And then we were able to fit 24 of our devices in the same space. But if you look at the camera here, you can see we're actually running live through this demo 40 amps through the both boards, and you can see the ideal switch. The maximum temperature is about 65, 66 degrees, and the silicon carbide devices, just because the on resistance is higher, you're running at about 118, 119 degrees. So pretty appreciable difference in the thermal performance for a given unit area.
Not quite 2 to 1, but yeah.
Yeah.
Okay.
And then this is just kind of showing you if you can see on this chart, this is showing a comparison of the dark blue and the dark red as the on resistance of these 2 arrays. So we're actually starting at about 1.4 milliohms with the ideal switch version. And really importantly, as you go up to 60 amps, you only get about a 25% increase in the resistance change, so up to 1.77 milliohms. The silicon carbide, as you get much hotter, it starts at 3.3, but you can see, semiconductor devices are going to increase by a much larger order of magnitude as you increase the temperature. So that's really what we're trying to demonstrate. Is some of the applications are for power relays and solid state circuit breakers and control applications.
Okay. Yeah. All right. Very good. Thank you, Chris.
Thanks, Martin.